Hello, welcome to session number 9 in the series Microwave and Millimeter Wave Circuit Design. I'm Anurag, and last session I presented to you a LTCC process from Faro, which is an all silver uh, metallization process. In this series, I'm going to continue designing some more passive circuits, like for example, one more passive circuit which is of a tremendous use is a hybrid 90 degrees hybrid. So hybrid can be used to design quadrature mixer. It can be used for isolation between two ports, and then still be able to divide the power into half. And it can also be used in designing phase shifters with a continuous phase shift rather than a digital phase shifter. So hybrids can be put to a number of uses. It can also be used to design Dorothy amplifiers, cascading them. So hybrid is used in number of designs. So what I'm going to cover now is a very quickly a hybrid design. So I'm going to make a new folder and call this as a hybrid. Okay, so in this I'm going to make a new schematic and call this hybrid 90. Okay, now what I'm going to make sure is that I design this line, right? And in this line I want to see, okay, so forget about the FEM simulation or whatnot. Okay, just want to see whether the line was 90 degrees. So I will plot the phase of S21. Make sure it is a 90-degree line. So what's the output? Not FEM. Let's look at the. So I am plotting FEM. No. So that is inaccurate. So I want to go from MOM. Uh, Microshift 50 ohm adaptive. That's the one. Phase. Okay. So at 10 gigahertz. Okay. Forget about 0. My interest is 9 to 10 gigahertz, right? So at 10 gigahertz, let's zoom in. So this is this part of the curve, right? So at around 10 gigahertz, we are 90 degrees, right? So this is a 90-degree line at 10 gigahertz. So that's great. So we don't have to do anything other than just copy this layout, whatever the line is, right? So let's go ahead and make one more line, and I'm going to make a line. So micro uh, strp 35. Okay, so let's calculate what is 50 over square root of 2. So I'm going to go to a calculator and I'm going to say uh, square root of 2, and or rather 2 square root. So that's that. And if I was to invert that, that will be 1 by x and multiply this to 50. So I have to design a 35.35 ohm line. 35.35. Okay, fine. So I'm going to go to tools, line cal, and start line cal. I'm going to put the substrate information here. So epsilon is 5.92 and the height is 10 micron, right? So height is 10 micron, thickness is 9 micron, right? And then this is 6.17 because it's silver, and 10 delta is 0.02, 0.02. So that's the LTCC process, right? So I'm going to design a 35.35 ohm line, right, which is going to be 90-degree long. Okay, and I want the results in micrometers, correct? And I hit synthesize. So once the synthesis is done, uh, oh, this is a 35.35 ohm line, right? So let me check if there's something wrong here. Epsilon height is 10 micrometer, right? No, that's the problem. 97 micrometer, sorry. 97 micrometer. Okay, so the width of the line is 251, right? And the length is 3571. So I'm going to do one thing. I'm going to write this down. Or rather, I will just design it, so don't worry. 251 and 3571. 251 and 3571. 251 and 3571. So this is going to be 35.35 ohm line. 35.35 ohm line. Correct. And then we have a 50 ohm line on the same substrate. So let's try that 50 ohm. And hit synthesize. So it should be 139, right? 3692. 139 and 3692. 139 and 3692. So that's a 50 ohm line. So now we have both the lines, right? So let's go ahead and do a layout of this line. Just new layout and create layout. So I'm going to make a line. So I'm going to use metal 7, right? And I'm going to place this at the center. So if I go to insert coordinate entry, so I'm going to place this at the center. Say apply, and then the height is 251, right? The height is 251. 251, and the width happens to be 3571. 3571. Correct. And say okay. So that's the line. Next thing what I'm going to do is 3571 quadrature, right? So basically I will just make another line on M6, which is going to be 3571. Okay, and as I told you, I'm going to put a quarter wave ground on both sides. So I'm going to just rotate this, place this corner here, extend it up to here. Then I'm going to repeat the structure like this and extend it back like this. And I'm going to delete this. So I have a line where I can put two ports, which is port 1, port 2, port 3, and port 4. So we have 4 ports, right? So it's only that I have to take port number 3 and change the metal to metal 6, right? So that is done. And then over here I have to go and change the port 2. So this is port 2, this is port 4, and that is ground reference on metal 6. So once this is done, I am going to, so let's do a view all on this. So I'm going to look at the EM setup, and here everything is fine. It's just that the port definition, I'll go and declare the reference ports. So 3 is reference to 1 and 4 is reference to 2. So once that is done, I can look at 3D EM preview. Okay, so the ports are looking fine, right? So these ports are looking fine here, right? So we are all set to simulate this line. It's just that in the port definition, right? Sorry, in the port definition you should have put 35.35 here. So edit port this thing and put here 35.35, 35.35, and that will be the center of the Smith chart, right? 35.35. That's the center of the Smith chart. Correct. So that's done. Go back and verify if that change has taken place. Then go to frequency plan. I'm going to go 9 to 11. So I'm going to go from 9 gigahertz to 11 gigahertz. And I am going to have all generated frequencies current saved for that. Under mesh, I will do a edge mesh and transmission line mesh. Then under model, I will generate a EM model, and I'm ready for simulation, right? So I'll simulate that. So it's going to mesh this, and I'm going to make sure that this is 35 ohm. Even if it is not, what I have verified in the previous session is that EM Pro FEM just is very, is validating that the line cal, line cal is very accurate. So I'm going to not change it even if it is not 35.35. It has to be in the same ballpark. That's the whole idea, right? So it has to be near the center of the Smith chart. Okay, so I'm gonna go ahead and look at S11. So S11 and S22. Okay, so they are dead center here. You can see that. So I have no problem with this line. Okay, so next what I'm gonna do is I'm gonna say save this EM clear mesh, save it again. Okay, so I have two lines. One is 35.35. Okay, and the other line which I have is going to be, just a second. So you can save this if you want, but if you don't want, you don't save that. So other thing is I have a 50 ohm line. So that's a 50 ohm line. So I'm going to make a new layout. So I'm going to say file, say new, or rather, let's say inside hybrid, I will say new schematic, and I will call this as hybrid 90. Create schematic. Oh, okay, cancel that. So what has happened is this particular file 35.35, actually I named it hybrid, so I'm going to rename this cell. Rename this to uh, uh, just one second. Let's see inside the line. So that's 35. Okay, fine, doesn't matter. So I'm going to make a new layout for this one, and here I'm going to say create layout, and I'm going to copy first a 35 ohm line, correct? So where is the 35 ohm line? So this one is 50, this one is hybrid, and this one is 35 ohm line. So I'm going to copy this one, Control C, and I'm going to paste this, Control V. So I'm going to say insert coordinate entry, and I'll paste this as 0 0, the corner to be at 0 0. Say OK. So this is a 35 ohm line. Next I'm going to take a 50 ohm line. So I'm going to copy this, Control C, Control V, and I'm going to rotate this, and I'm going to place it at the center like this, and another one over here at the center. So just one second. Before that, let me just match centers to centers. Yeah, that's fine. So this is one line, and I'm going to repeat that line over here, center to center. Okay, done. Next is I'm going to repeat this line at the top. Okay, now this is a, this is something which sorry, I should have copied that. This is something which I've been trying to tell you for a long time now. See, everywhere in your designs, okay, those 10-year, 20-year-old, designers, especially from Indian defense or space, what they do is everywhere in their schematic they will put these transitions, bands. Well, yeah, they are okay, but they are overkill. You should know when to put them and when not to put them. You are dealing with frequencies which are, not very high, and even if they are high, the dimensions shrink. So these bands really, they will not do a lot to your design. Rather, if the width of the line is in error, it's going to give you much more error. So this percentage error due to the joins and the pads and everything, this is very small actually. You do not need to put that in your simulations. And this is from my experience I'm telling, right? So now let's say this line is there. This is a 50 ohm line. I'm going to repeat that line over here, or rather I can extend this line, right? So this is a 35 ohm line, and I need a 50 ohm line. So I'm going to rotate this. Okay, and right now I can shrink this to a very small value. Maybe this is good enough. Any number doesn't matter. Okay, and I'm going to place it over here. Okay, so that's a small line, piece of line. You can extend to any extent you want. If you want, you can make it double. Doesn't matter. It's just that you should know that the phases will be in will be referenced to something rather than being absolute numbers. So okay, and I'm going to repeat that. That would come over here, and another one would come over. So this is a 50 ohm extension because this port is become 50 ohm. Correct. So now we are done with it. So I'm going to take everything and say edit merge union. Say okay. So this is all merged. So this is a hybrid, right? Now I am going to go and make the same extension of the ground plane. So if I go to M6 and I say I have a ground plane from here to there, so then what I'm going to do is I'm going to just repeat it. So this ground is from here, right? And then I'm going to repeat this ground over here. Now, oh my God. Okay, bear with me. Okay, so now I will extend this up to here, get rid of this guy. Now, somebody would say, oh, the ground effects are going to kill you. This will no longer remain 50 ohm line. Well, let's check it, right? That's one thing I can say. Another thing is, if you are so bothered, right? So I can do one more thing. If you are so bothered, I can repeat this structure. This is a ground plane, correct? And this is a ground plane here. And then, sorry. Okay. And if you want, I can just merge them and put a slot in between. So let's say M6, I'm on M6. Let's say I have a slot like this, right? So I'm going to move this over here, and I'm going to put two slots like this. So really I want to put in an internal form of not an internal port exactly, but I want to put in here a local port here by making the ground discontinuous. And this discontinuity is not going to affect you because it is so small, right? So let's say this. Okay, so I can select this and say edit merge union minus intersection. So that's the first slot you have. The second is I can select this and say edit union minus intersection. Union minus intersection, and then I can select this and say edit union minus intersection, and I can select this and say edit union minus intersection. So I'm done with this, and I can merge all three of them and say edit merge union. Okay, so what I have created some slots in the ground, and they're so small that they are not going to hurt you. So now I'm going to place ports. So this is port 1, this is port 2, this is port 3, and this is port 4, correct? And then there is port 5, port 6, port 7, and then you have port 8. So now I'm going to change their layers. So port 1 and then port 5. Port 5 is on 6, metal 6, right? Then port 2 and 7. So port 2 and 1 2 3 4 5, right? So here port 1 is on 7 and 5 is on 6, and here 2 is on 7 and 6 is on 6, right? And then over here 3 is on 7 and 7 is on 6, correct? And over here 4 is on 7 and 8 is on 6. Okay, so having done that, I can go ahead and create EM, okay, and here I can go to ports, and what I'm going to do is 1 2 3 4 ports. So 5 is reference to, sorry, so I have to go to port editor. Okay, so here 5 is reference to 1, 6 is reference to 2, 7 is reference to 3, and 8 is reference to 4. So this is done. I'm going to save it, and here I am going to open this again, and you see our ports are done. Now I have a plan, so I'm going to go from 9 to 11, and I'm going to save for all frequency the currents, mesh, edge mesh, transmission line mesh, and then model, and show that the EM model is created. So anything else I have to do here? Nothing, right? So this is done. So what I'm going to do is I'm going to go here ahead and hit the simulate button. Okay, so this is going to be simulated. So before that, let's look at a preview whether my ground references are correct. So if I look closer, so all are having their correct ground references, so I'm all set. So I'm going to hit simulate on this one. Okay, so we are done. I'm not looking to what is the template. I want to look at S11, S22, S11, S22, unless I have done a blunder. S33, S44. They will come close to 50 ohm. So they are close to 50 ohm. Now how close they are, so I'm going to go here, Control C, Control V, and I am going to, so I need in dB, right? So what I'll do is I will put here S11 in dB, S22 in dB, S33 in dB, and S44 in dB. Okay, so it looks like at 9 gigahertz I have around 13. Not bad. So let's look at what happened to S21. S21. Okay, S21 should be 3 dB down. So it is close to 3 dB. Okay, now what's happening is at 9 gigahertz it's close to 3.9, so 0.9 dB is the insertion here. So let's look at S31, which may be slightly worse. Okay, so it is not worse, it's okay. And let's look at phase of 21 minus 31. So I'm going to look at phase of 31 minus 21. So 31, add phase, okay, and I'm going to go to trace expression minus 21. Control C, Control V, and here I'm going to put 2 and say okay and okay. So there is a unwrap issue. So I'm going to put here unwrap. Okay, so this is a unwrap. Okay, so now they are differing by 90 degrees, slightly off. The worst case is 3 degree, so 2 point something off, but they are close to 90 degree, right? You can fine tune this, right, by adjusting the lens. Okay, how do I know? If you look at the phase of S21, for example, it should be 90. Sorry, phase of S21 should be 90. Now, is it 90? Yes, it is 90 at 10 gigahertz. Let's look at the phase of S31. Okay, now I have to put an unwrap here. Okay, so unwrap across this unwrap. Okay, so it is 180 right here, slightly off. How much off? 178. So basically the line which is the culprit is, both lines are culprit, so they are smaller actually. Those lines have to be slightly bigger. Now let's see how good is the isolation, because there is a 3 degree error, right? So let's look at S41 and how good that is or bad that is, whatever way you see. Okay, so the isolation, okay, between 4 and 1 is 15 here, right? Minus 14. And at 10 gigahertz, 10 gigahertz, it's 25. At 10.2 gigahertz is 47. Now, can this be improved? Yes, can be improved if you adjust the phases. So I'll do one iteration. So I'm going to say EM clear mesh. So I would have to move these points. All the points I have to move actually. So I'm going to take all, okay, so all the points I have to move. So can I move the ports? Yeah. So kind of messy, isn't it? Kind of messy. Okay. So I'm going to delete this. I'm going to delete that. I'm going to delete this one. I'm going to delete that. So all the ports are over here, and I'm going to move one of this port. So outside the body, this and that. Okay. So what I have learned is that the lenses are slightly smaller. So I'm going to edit, move, relative. Okay. 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 So instead, okay, so what is this dimension? This dimension is 3800. So if I was to reduce this by, let's say, 20, and people may say why reduce, I'll tell you. And if I reduce this by 20, so it'll go up by 20. Okay, it has gone up by 20. Now I'm going to put back these ports, right? So I'm going to put back these ports where they were and hit simulate again. So I'm not going to do many iterations. So this is, you can design this and you can figure out the best isolation and the best insertion. It's all up to you. I'm just showing you the way. Okay, so this is done. So we are still fine. I'm going to hit EM, say all ports have moved, right? And I'm going to hit simulate. Okay, so it's going to replace the files. That's okay. So it has meshed it, simulating it. Okay, it has become worse. So here it has improved. It has moved to the right, right? And what happened over here? It has become worse. What happened over here? The phases have improved though, isn't it? Yeah, so we were right. It should have moved to the right. So what I'm going to do is go back to this. This is kind of infectious. Okay, so I'm going to do undo, 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 and undo, undo. Okay, so now here I'm going to do plus 20 now. So you will have an idea of what's happening, right? So I'm going to do here edit, move, relative, or let's say plus 30. Okay, so this has gone up, and this is going to be minus 30 on Y, minus 30 on Y. Okay, let's see if it moved. Yes, it did. Okay, so now I'll put back the ports. So this one goes here, this one goes there, and this one goes there. Sorry. So this one goes here. Okay, so we are done with this. Okay, so let's simulate this again. Ports have moved, fine, doesn't matter. Save it, and let me shrink this and hit simulate. Okay, so let's see what happens now. So I'll put the simulation to the right side so that when it finishes, you know it. Okay, so we can nicely center it. That's what I'm saying. So this is improved. This is improved too. This is improved too. Okay, so now that's there. Okay, so all I'm trying to say is that this design is easy. It's not difficult, right? You might use it for a smaller band. Maybe you will use it for 9.5 to 10.5, right? So it really depends on. Now, if you want to make a broadband hybrid, okay, you can also do two lines in parallel on these and tune them out and separate them out and make it broadband. So there is already a paper in IEEE how to design a broadband hybrid, and that the author is basically splitting these lines into two, and then adjusting the impedance and the lengths such that he gets a broadband response from a hybrid. So I'm gonna stop here for the hybrid. Let me see how many minutes. Okay, so this was a quick video on hybrid design. Okay, maybe some people may be interested in seeing this. Okay, so I'm going to put in power at 10 gigahertz around. So I will go to solution setup 10 gigahertz. In port 1 I'm going to put the power and put the animation on and adjust this to 1 so that now you can see. Okay, let me see which one is 1 and 2. So this is, hang on, this is port 1, so that means that this is port 4, right? So let's do this way. This is too much, isn't it? So let's say that this is 5. Okay, so why is this lighting up? Okay, this should be a silent port, isn't it? Maybe, okay, it is showing that two reach in the same phase and they might cancel. So it may be the magnitude, right? Okay, okay. So I'm gonna stop here. So this is fancy to look at, but other than that, I expected something different. Okay, let's look at the arrows. Okay, so too big the arrows are. Uh, Now that is better. And contours. How about the ground plane? I don't see the arrows in the ground plane. Right. Shaded. Okay. So you see why this is port 1 and this is port 4, isn't it? Arrow. 5. What frequency I'm looking at? 10 gigahertz. Contours. Division. Hmm. Okay, probably I'm not able to show the thing in the ground plane. Maybe if I don't make the substrate visible, what's going to happen? All substrates are gone. Actually, in EM Pro, you could plot the arrows in the ground plane. You could see the current in the ground plane. I'm interested in this port. 90 and 270 degrees. That's what I expect. Anyways, so enough of playing around. So I'm going to disable contours, disable arrows, and I'm going to put shaded back. Right. So that's your hybrid. Thanks a lot. Thank you.